Hi everyone. Today let us learn about the solid principles in Java. There are five design principles in Java. They are a single responsibility principle, open and close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. These are the five principles that are present in Java. They have been used to improve the software maintainability and scalability. Let us learn each of the principle in briefly one by one with an example. The first one is a single responsibility principle. This principle states that the class should have only one reason for change. That means and the it should have only one job or only one responsibility. The class should have only one only one reason to change. The class should have an only one reason to change. It should have only one responsibility or only one job. Let's see by using an example. See here I take one class with it is doing two tasks, that is an calculating of the total and printing of it. But what the single responsibility principle state that it should have only one job or only one responsibility. Instead of having two these two tasks, that is calculate the total and the printing, handling both of the tasks within the one class, we have to split it. Here see in down I have splitted both of the tasks for a single classes. In the above example I have taken two tasks in the same class, but in but here I have split it of the both the tasks within separate class. See for this class I have taken only one um task. For this have been taken only one task. Here it is doing and calculating of the total, and here it is doing and printing of the data. That means if you're seeing the single line only, we should be able to say the what the task is it is doing. This is the single responsibility principle. That means class should have only one job. You see, this class is having only one job. You see, this class is having only one job. If we have the multiple tasks in within the one class, we have to split it them. So we have to split them. That's it. And then the next one is an open and close principle. Next principle is an open and close principle. This principle states that the software entities has been opened for the extension but closed for the modification. Software entities should be opened for extension but closed for the software entity should be opened for extension but closed for modification. What it means, I'll explain with the example. See, I have taken one class which is an abstract class. I have been taken. I have taken two abstract method, that is a draw method and a done method. We already know that what are the abstract method is present in the abstract class. Each of the abstract method has to be overridden in the extended class. I have taken one X square class with an extended shape. Both of them have been overridden here. Both of the abstract method have been overridden. How many classes if we create which extend the shape, that extend an abstract class? Whatever the methods that are present in the abstract class, that is an abstract methods, each of the abstract method has to be overridden in the extended classes. See, I told you that the open and close principle state that it is open for extension and closed for modification. That means open for extension means if we add the new features, in wherever in the code, it should not disturb any other code. It should not disturb means if we add now here I have one more method, void stat. See, I've added one more method here. That is a new feature have been added here, but it is not disturbing the existing code. I'm not getting any error in the existing code. That means it is open for extension. This is an open for extension. If we add new feature, it should not be disturb the existing code. Then close it for modification means whatever the code I already have, if I change somewhere in the code here, see in the abstract method I have taken a draw method. I'll take an stop method. If I use a stop method, I'm getting an error in the class square and class circle. So if add a new feature or if we add something new, it should not disturb the existing code. But here I'm using some other method, but or I'll take one more. I'm using this and draw only. I'll take one more abstract method. Abstract void stop. See, if I'm taking one more abstract method, but I'm getting and some error. I'm getting some error. I'm getting some error. If we add new features also, it should not disturb the existing data, existing program. It should not disturb the any changes in the existing program. But if I add this line, I'm getting some error. Should not do like this, and we should not modify it. It is closed for modification. Means whatever the existing data is there, if I change somewhere in the existing data already present data, if I change here, I told it that I use your stop method, I'm getting an error. So I'm getting error in the square class and then circle class. So for this reason, it is closed for modification. This is about the open and close principle. Now the third one is an Liskov substitution principle. Third one is an substitution principle. The third one is a Liskov substitution principle. This principle states that the superclass object should be replaceable with the object of subclass without affecting the program. Let us write that. Superclass object should be replaceable with object of subclass without affecting the program. The superclass object should be replaceable with the object of subclass without affecting the program. This is an Liskov substitution principle. For example, I have taken class that is an bird class, and taken an a method as an void fly. We already know that the function of the bird is fly. It will fly. Bird will fly. I taken one more class. It is a sparrow class, which extends the bird. That means, see, here the sparrow will also fly. The function of the sparrow is also fly. It is matching with the superclass. The subclass function is also matching with the superclass. See, but one more example taken, that is class as a penguin, which extends on bird. The penguin is a bird, but the function of the penguin, it will fly. No, it can't be able to fly. The penguin inherits the bird. That means it extends the bird feature, but it can't fly. So it is violating the exception behavior. It is violating the behavior. But the penguin can't be fly. It means the both this superclass and the subclass should be behave as like a same. See here for this bird class which I'm extending for a sparrow, both the bird will fly, that the sparrow will also fly. But here the bird, the penguin, we can't be fly. So that means, and if we replace an superclass object with a subclass also, that is and sparrow also, but it should be same. It should not affect the program. That means here the bird is fly, that sparrow will also fly. It is not affecting any of the program. Both the functions are same. But here if we come for a penguin, see it is violating the behavior, that is, and it can't be able to fly. This is about the Liskov substitution principle. The fourth one is an interface segregation principle. The fourth principle is interface segregation principle. The fourth principle is an interface segregation principle. This principle said that the client should not be forced to depend on interface it does not use. Let me write that. Client should not be forced to depend on it interface it does not use. The interface segregation principle states that the client should not to be forced to depend on the interface because it does not use. Say I take one more example for this one is see here it states that the client should not to force on the depend on the interface, right? See I taken one interface that is a job. We already know that interface contain a collection of abstract method. It does not contain any concrete methods. Abstract method means any method that ends with a semicolon or a method without body or any method that ends with a semicolon or the abstract method. See, I've taken your interface as a job. I've taken all the abstract reason. I'm taken an four abstract method. Right. I'm taken an four abstract method. If I take one class, if I take one other class that implements the job, I'm taking a print, but I'm taking here, I'll show one. I'm taking one class, the class name as a sample. I'm implements this job. Going to implement this job interface. See, if I'm implementing, I want to get only for and to get an only an abstract method print. I need only an abstract method print. If I take a class with implement the job, but it should override all the abstract methods are present in the job. But I need only one. I need only one print abstract method. I need only one print abstract method. But if I use only one print abstract method, but I'll get an error on that time. If I use only one print abstract method, I'll get only error on that time because whatever the abstract method that is present in the interface, each of the method has to be overridden. But I don't need all the other methods. I need only one print method to resolve this problem only. We are using an interface segregation principle. You should not to force on the client should not be forced to depend only on the interface because it does not use it. Instead of using like this interface with a lot of these abstract method, say I taken interface with only one abstract interface with another abstract method, interface with another other abstract method. See, now if I take and one class which implement a printer, now I'm taking a printer I'm taking it implementing and printer interface. So going to override only the printer method, only the print abstract method. I'm going to override only print abstract method. If I need the scanner interface, I'm going to override only the scan method. I'm going to override only scan method. Whatever I need, I'm going to override that abstract methods only. If I use like this, I have to override all the abstract methods. By splitting of these interface with a single abstract method, whatever the method I need, only those methods I am going to override. That means we have to avoid forcing the class to implement unused methods. See, I'm implementing, I'm overriding all the abstract methods. I need only one print method, but I have to override stat method, stop method, and then this scan method. I have to override all these methods. I have to override all these methods. Instead of like that, if I split off like this, then I can override only which are the methods I have been needed. I don't need to override what are the unneeded methods, that is unused methods. See, now this printer now can implement only the interface. It will implement on what are the interface I need. And that means interface should be also be small, but your interface with a lot of abstract method. That is a four. There's also a lot of abstract method. Instead of like that, I'm going to split it down the each of the interface within one abstract method, and then I can implement whatever the abstract methods I have been needed. That is about the interface segregation principle. Now the last one is an dependency inversion principle. The fifth one is an dependency. The last principle is the dependency inversion principle. This principle states that the higher level module should not be depend on the lower level module, but both should depend on the abstraction or interface. High level module should not be depend on low level module. Both should depend on abstraction and interface. High level module should not be depend on the low level module. Both should depend on the abstraction and interface. Go for this example. See, I taken one interface with an switchable. I'm taken two abstract method is an void turn on and void turn off. These are the two abstract methods. See, I'm taken one class that is an light bulb which implements the switchable interface. So I'm going to override both of the abstract methods in the implemented class that is an light bulb. Both of them has been implemented. This is an low level. This is an low level mode which is the implementing the switchable interface, that is an both the high level modules and low level modules can be dependent on the interface. This low level module has been implementing the switchable, that is an interface which is implementing the switchable interface, that is depending on the interface. See, for this example, I taken one more class. This is a level which is depending on depending on the interface. This high level. This high level is depending on the interface. Means the switch is depending on the abstraction. This switch is depending on the abstraction, that is an interface, that is a switchable interface, but not on the concrete class. Not on the concrete. This is about the uh, last principle, that is a dependency inversion principle. These are the principles which are present in the Java. These principles can be also asked in your interview if you have more than 3 to 4 years of experience. Thank you. I'll end off here. Thank you.